This is the review of area, law of sines, and cosines. So, a review of area problems, review of law of sines problems, review of law of cosines problems. So, the first set of problems here is find the area of each triangle to the nearest tenth. So, if you're given two sides and the included angle, you can use this formula right here, that the area is equal to 1/2 AB sine of C. Once again, side A and B are the sides that surround the angle C, so angle C would be the included angle, and A and B would be the two sides there. So the first one there is 1/2 8 times 4 sine of 125, and you get 13.1 square inches. So for this first one here, let me go to the Desmos calculator. So here it is right here. Let me X these out here so you don't get confused what's going on. So one thing you need to do is go to this wrench symbol and make sure you're in the degree mode. And then this first problem is 1/2, so you do 1 divided by 2. So 1 divided by 2, and it makes a 1/2. And then you want to get the cursor next to 1/2, so times, and then 8 times 4, and then sine of 125. So 8 times 4 times sine of 125. Whoop. And here's the answer here, 13.1. I go back here to my worksheet, and sure enough, 13.1 square inches. So the rest in this section, 2 to 6, are very similar. You're just plugging into the formula. So number 2, area is 1/2, 4 times 10 times sine of 70, and you get 18.8 square meters. And number 3, area is equal to 1/2, 13 times 15 sine of 135. So the area is 68.9 square kilometers. Number 4, area is equal to 1/2, 8 times 8 sine of 70, 30.1 square inches. Number 5, the area is equal to 1/2, 14 times 10 sine of 110, which is 65.8 square centimeters. 6, area is equal to 1/2, 16 times 13 sine of 80. So the area is 102.4 square meters. So this worksheet here is the one I gave you on Friday, March 13th. So if you have that worksheet and attempt it, you should take a look at it and see if you did the problems correctly. If you didn't do the problems, then I would take out that worksheet and try them before you look at this video, and then check your answers with the video. So the second part here, these triangles 7 through 12 are all using law of sines here. So when do you use law of sines? When you're given angle, angle, side, angle, side, angle, or side, side, angle. So this number 7, you're given angle, angle, side. So you start with one of the givens and then work your way around the triangle. So this one here, angle, angle, side. Number 8, and then number 9 is angle, side, angle. So that one's a little different. You have to find this angle F first. When we get to this one, I'll explain to you how that works. And then over here, this one is side, side, angle. Number 10 and number 11 is side, side, angle. And number 12 also side, side, angle. So 10, 11, and 12, we really should check the ambiguous case, but I'm not going to test you on that. But just know that if you're given the donkey theorem, angle side side, then you need to check to see if there's one triangle, two triangles, or no triangles. So the way you find out there's no triangles, if you get the inverse sine of some ratio that's greater than 1 or less than -1, then that won't work. There wouldn't be a triangle. And then you would have to check once you find one of the angles. Like here, if I found 44, I'd take the supplement of that and see if the supplement added with 78 is less than 180. So there would be a second triangle. Otherwise, it'd just be 1. But you don't have to really worry about that. I just wanted to mention that sometimes there's an ambiguous case when you have the donkey theorem, the side angle, where this backwards spells the donkey word there. So starting with number 7, you have sine of 44 over 23. So sine of the angle and then the opposite side. And then sine is 75, and you're trying to find out what this is. So since this is angle x, then I can call this side x, which is the same as yz. So here I have a proportion. If I cross multiply, I have x sine of 44 equal 23 sine of 75. And then when I divide both sides by sine of 44, then I end up with x is equal to 23 sine of 75 over sine of 44. So let's go to our calculator for one of these. So let's go with this one here. Show it to you on the calculator. So number 7, 8, and 9 are pretty similar, but let me just do one of these on the calculator. So I have 23 sine of 75 divided by sine of 44. So on the calculator, so if I just hit the division symbol, then I have 23 times, and then find the sine, 75, and divided by sine of 74. So function key, sine 44. And I should make sure I'm in degree mode. I am. So 31.98. Going back to my worksheet, at 31.98. Sure enough, I got the same answer on the calculator. So I would suggest going to the Desmos site when doing laws of sine and cosine, so you can use the function keys there. All right, so 8 and 9, similar to that. So if I want to find EF, that's actually side D, so that's why I called it side D. There, so sine of 96 over 38 is equal to sine of 39 over D. And then when you manipulate that equation, cross multiply and manipulate the equation, then you have D is 38 sine of 39 over sine of 96, 24.05 centimeters. DF is actually this side right here, which is the same as this is angle E, then this is side E. So that's why I use that. And this one's a little different because you don't have angle F, but you have these two angles. And you know there's 180 degrees in a triangle. So angle F is 180 minus 39 minus 61. Angle F is 80. So every time you're given angle side angle, you're going to have to find the third angle in order to use law of sines. So now I have sine of 80. That's this angle over 36 is equal to sine 39 over what I'm trying to find here, side E, or same as DF. So E sine of 80 when I cross multiply equal 36 sine of 39. So E is going to be 36 sine of 39 divided by sine 80. And you have E is equal to 23 inches then. All right, so 10, 11, and 12, you're trying to find the angles there. So if I want to find H Number 10 of sine of 78 over 38 is equal to sine of h. I don't know what that number of degrees is. That's what I'm trying to find. Over 27, and then cross multiplying 27 sine of 78 equal 38 sine of h. And then h, when I divide both sides by 38, is equal to 27 sine of 78 over 38. So in order to find the angle, I have to do the inverse sine of this ratio here. So let's go to the calculator again. So inverse sine of 27 sine of 78 over 38. So let's go to the calculator. So I'm going the inverse sine. 27 sine of 78. So let's hit the divide key. 27 times sine of 78. And then in the denominator is 38. Here's my answer right here. So 44 degrees. I go back to my worksheet. Sure enough, 44 degrees there. So 11 and 12, you're doing a similar problem there. You're trying to find the angle. So if I want to find angle R, that's this angle here. So I have sine of R over 13 as one of my ratios, and the other one would be sine of 101 over 34. Equate those two, so it becomes a proportion. Cross multiply, and then sine R is equal to 13 sine 101 over 34. To find R, you need to do the inverse sine of that ratio. You get 22 degrees for the angle there. And then number 12, if you want to find D, here's angle D. You don't know what that is, so sine of D over 22, that's right here, is equal to sine of 40 over 23. When I manipulate that proportion and solve for D, I get 37.9 degrees. All right, and then on the second page here, why it's going to. All right, so when I have side angle side or side side side, then I'm going to use law of sine. So number 13, side angle side. 14, side angle side. 15 is side angle side. 16, 17, and 18 are just side side side. That's the given information, side side side. So you have to find an angle there. And here, if we want to find a segment, if I want to find HK, I'm going to call that C. I don't know what it is, so C squared. And then A and B can be either the sides that are remaining there. So I just always use the larger number as A and the smaller number as B. So 25 squared plus 12 squared minus 2 times 25 times 12 cosine of 104. And then to find C, you have to take the square root of that whole expression there. And you have C is 30.23 inches. So make sure when you go on the calculator that you're doing the square root of everything there. In other words, get everything under the radical. So let me demonstrate that. 20 square root of 25 squared plus 12 squared minus 2 times 25 times 12 cosine 104. So let me go to the Desmos calculator to demonstrate, excuse me, how to do that. So I pick up a blank spot, and once again, make sure I'm in degree mode. And then I wanted to get the square root. So 25 squared plus 12 squared minus 2 times 25 times 12 times cosine of 104. And I get 30.23 for the angle. For the side. So 30.23 inches for the side. And then 14 and 15 are similar. You're trying to find a side. So if I'm trying to find RS, that's going to be my C in the law of sines equation. So C squared equal A squared plus B squared minus 2AB cosine of C. So if this is side C, then 89 is angle C. When I take the square root of both sides, I end up with C is approximately 29.1. And then the same for 15. I'm trying to find QR. So that means 106 is my angle C. And I'm trying to find side C. So like I said, I just use the larger number as A and the smaller number for B. And then when I manipulate the equation, take the square root of both sides, C is approximately 33.8. And then 16, you want to find angle S. So that's going to be your angle C. And then this side across from S is going to be your side C. So 15 squared equal, and then A and B, I just use the larger for A and the smaller one for B. And then when you manipulate this equation, you have to subtract both of these from both sides. So that's how I got the next equation, subtracting 24 squared and 21 squared from both sides of the equation. Then that equals negative 2 times 24 times 21 cosine of C. So the inverse of multiplying is to divide both sides by this. So now I have cosine X is equal to 15 squared minus 24 squared minus 21 squared over negative 2 times 24 times 21. So you want to do the inverse cosine of this ratio, and you get 38.2 degrees. So once again, you're going to go to the Desmos calculator to do that, to manipulate that, or to calculate the inverse cosine there. And once again, make sure you're in degree mode on the Desmos calculator when you do that. So 17, at some point, you might just want to say skip from the original equation down to here. So if I skip from the original equation, here it is. So I'm trying to find angle E. That's this angle. So 23.2 is side C, and the other two sides are A and B. So here I plugged in the equation. You could skip down to here. So E is going to be inverse cosine of 23.2 minus 23.9 minus 13.9 divided by negative 2 times 23.9 times 13.9, which is 70.1 degrees. And then 18, I skipped a few steps there, so I just went from here to here, an inverse cosine of this ratio, and you get 103.14 degrees. So once again, this is a worksheet that I passed out before the break. If you're absent, then you might want to kind of just copy the problems first and then come back to the video to look at the answers. So try to do some of the problems on your own. It's like on this side here, I would do one of these three because they're all the same. And then one of these three, they're all the same. And then maybe do two of these because they're all the same. And then down at the bottom, maybe do number 7, number 9, and then one of these three, 10, 11, or 12.